what we are doing and why it's cool that we are doing test automation. Typically, testing isn't thought of as any of the like cool things to do in a sense. So it's just verification. It's people telling us that we've done something wrong and something like that. I don't see it like that. I think it's one of the nicest enablers now of really fast software iteration and like progressing of technology now on that side. And what I also do is I'm also a PhD student on software engineering. So I'm doing my finishing my PhD this year. I should defend my thesis at the end of the year on software startups and how software startups iterate on software methodology and how do pivots and product strategy relate to startups. The topic is still not 100% finished on what the title of the thesis will be, but that will happen this year. And something about that, where are we from, basically? We, as Dirk said, we're a Finnish company, and there's a lot of Finnish ideas behind it. But one of the things is that Finland has typically known for quality in the stuff that we do. For example, the Nokia 3310 is kind of one of the most famous phones for this quality, and it's been on a lot of internet memes and all of that, but because of the fact that how rigid and how well behaved it is. And it's kind of happy to say that many of the people who are now involved in Qentinel have also been involved in Nokia back in the day and in these testing and development phases of it. But in 2008, Qentinel was founded as its own company, and Nokia is still, or 2006, but 2008 was one of the biggest open source initiatives that we had. And from those roots, we've kind of grown the company. So we're a quality company. We used to be a lot bigger. We used to be 150 people. What we did was we divested the consulting side of our testing automation business. So we are not a testing consultancy house anymore. We used to do that a lot. We used to do it to companies like Nokia and all the others in Finland and also abroad and also in Germany a bit, as Dirk and the others know, and also in the US. So what happened was that we sold that part of the business away, as we've been now focusing on Qentinel Pace, which is our kind of test automation tooling product and infrastructure product. And as I myself believe that most of the testing will get even more automated than it currently is, and it has to become more automated to kind of support the fast development pace that's happening everywhere, not just in software, but also in the hardware side and all of the other side that's also happening there. So we slimmed that down. There's only 24 of us now, and all of us are involved in product development or product marketing or just on the product side of the business. And we kind of ended up there because we felt that we've been repeating ourselves in all of the projects. So basically doing the same kind of test automation setup to many clients that we used to have on the consulting side. And we kind of productized that. And we're doing quite well now with the product on the cloud side. And we believe that many parts of the testing will go to the cloud and also use open source technologies. And one of those technologies that kind of came out of Qentinel is Robot Framework, which you might have heard of. I heard there were people from Focus also, though, who's been a test of that, and then a couple of people who might have also been part of Electrobit German or something like that, who've also been big users of Robot Framework. So that's something that came out of Nokia, and Qentinel. Qentinel basically did the Robot Framework for Nokia back in 2008, 2006, and then it was open sourced by Nokia. So that's one of our biggest achievements, maybe on the test automation tooling side. And kind of talking on the test automation side, I put in DevOps here as I think DevOps and test automation and not just testing relate to each other in kind of a nice way, and it is a nice topic. And I'd hope if you can get kind of a discussion going, or if somebody wants to say something or interrupt me or ask anything, you can always ask me on this topic. And all of that is kind of that DevOps isn't really a new thing. It's just the old way of building software that we try to make faster and kind of lean out many of the different parts of the project to get the development cycle going in a much faster way, which is enabled by automation. And this can be kind of compared to back in the day product lines, and DevOps can be thought of as a kind of like a product line for software, in a sense that you can quickly iterate, quickly get feedback from the market and iterate onto the next product. It is not optimized to build the same product many times, as of course in software side, copying of products is basically free, as you can always just copy source code. But when you have hardware in the loop, as for example in the automotive or IoT sectors, then it becomes a bit different. And that's one of the problems that we've been kind of working a lot with, is how we do IoT, how we do connected devices testing, how do we do software, or how do we do DevOps and Agile in an environment where there's a lot of software and hardware components intermixed in there. And we believe that kind of getting the loop of getting something verified quite quickly, packaged, released out to the client, and tested is one of the key things in DevOps, and getting that going on, not just in software side, but also on other product sides that can basically enable you to get faster customer feedback, which is always important in many of the sectors. And typically, even though if you'd have a longer update cycle, for example, in the automotive industry, we're actually kind of trending away from that. So it's going to change a lot. And when you kind of think about it against DevOps, it's culture, movement, or practice of collaboration, automating the building, testing, and releasing of software so that it can happen rapidly, frequently, and more reliably. This is basically the definition of automation in a sense. How do we organize humans to do stuff faster and collaborate with each other more easily so that we can achieve bigger things more rapidly, frequently, and more reliably? So I think DevOps is kind of like how automation is changing our culture and how it is changing many places in production lines, in software development. All of that. The basic idea is to build products or build some physical products even in there, and how that works. So coming back to kind of actual test automation and testing, the DevOps is kind of enabled by three things. It's actually the process. Typically, when you talk about manufacturing and you talk about all of software engineering, you talk about agile processes or that kind of thing, and that's kind of the core message. This is happening in many industries now, and of course you have the agile and lean movement also on the factory side, kind of trying to do the same thing. But it's not just about that process. You also have to have the infrastructure to support the process. So that might mean the big factories with big production lines that you need to enable faster processes, or with DevOps, you typically need cloud infrastructure that's happening now, that you have those build servers, you have all of the kind of supporting automation organization for you to do it, and architecture that kind of acts as a standardization between there, so you can actually do something quite fast and in a way that is testable and in a nice way doable in there. So kind of coming from the culture of humans towards actually automating something and doing it in combination with the automation of the machines and the humans. As basically any production line, not even on the physical where it works 100% automatically, you always need kind of human intervention, and the machines kind of work to boost the human efficiency in there. But even though if we could speed up this loop as much as we can, it's the problem in there is still the kind of validation. Even if we can do things faster and faster, the question of are we doing the right thing is still quite difficult to answer. And that's the kind of field of testing, and that's why I myself am interested in the field of testing, is that's the field that kind of asks that, are we doing the right things, and are we doing them in the right way? So kind of, is the thing that we're doing as good enough or safe enough or worth it to anybody in there? And that's why I've been getting into testing and Sentinel and all of the test automation side of things, and kind of how these three pillars build up on top of lean and all of the other side of there, and how can we kind of bridge that gap with the feedback flow and continuous learning to get that feedback from there with testing. Are we doing the right thing, and getting the data from customers? So two sides of it, and I kind of see that the testing is also something about this feedback and how you can get not just me as a tester doing testing work or enabling that some standard is working properly, but how to make your company perform faster, how to build this whole faster engine to kind of improve the lives of everybody through getting stuff out. It's not even about the kind of money side of it. Of course, that's a good motivator to get companies working better, but that's also part of building more value for the whole society through that. And how testing relates to that is basically this is the feedback cycle of testing in creating new products or new versions of a product. Typically, looking at automotive or some other areas where you do actual physical works where this cycle is super long. So you might have products coming out 2-3 years from development, and that's the normal time that it takes. But then looking at the other end, you might have a new version of a mobile application coming out immediately. You typically have different types of tests for software in there, which are not dependent on the actual hardware, or these could be done on the hardware side. You might have the kind of static checks to make sure that you've done the right thing on code, you've written the right word in there, and tested that one small thing that you've done as part of the team in the unit testing phase. Then you'd have smoke tests to see if there's any kind of major problems with it and integrated with bits that other people have done in there. And again, that takes some time. The times here, I stole this slide from other sites that I have. This is a typical time set for one telecom case that we've had, that this is the kind of typical times that this takes, that you can say that when you do testing, the bigger the scope of the testing actually gets. Are you talking about just one line of code? Are you talking about some unit of code inside of your actual product? Are you talking about putting all of those different bits of code made by different people together or teams together? Or are you talking about the whole system? And how long does that take to test in there? And the higher you go in abstraction level, the longer time it actually takes to do that. And it's really easy to check if you've written the code right. It's easy to check if your bit works. But the more complex the system becomes, the more difficult and more longer it takes to test. And this is becoming apparent in many of the systems that we are now building, as in many of the different industries. As, for example, of course, we are now talking about automotive. We are not just talking about just the engine and the ECU and that's it, as a standalone unit which has to work for 20, 30, 40 years. We are not doing that anymore, and haven't been doing that probably since the 90s. We've had all of these infotainment systems. We have all of these ECU and motor control systems. If you have a more advanced engine, you might have some turbo pressure controllers, a lot of sensors, a lot of fault management, a lot of different systems interacting with each other. So from those basic components, you are getting more and more complex systems which talk to each other in ways that might not be easily defined with any of the kind of standards or anything else. So the acceptance and system test phase is taking more and more time with these systems and becoming more and more complex to test. But even though with the 90s cars, it's kind of easy to do because the environment is in itself closed. You know what's happening in that environment because it's something that your company, for example, does, that you do cars. But now with the advent of kind of software-defined car and software-defined environments in IoT and other environments, you are not anymore controlling that environment. It's connected basically to the internet, and the internet is, in a sense, quite a hostile environment. So if you're connected, the environment of the internet forces your applications also to adapt, which says that you have to do updates quite frequently to your software, which means that you have to test it frequently. But because of the fact that this acceptance testing, it's getting more and more complex. It's not actually even the implementation of the new features or making of those, even in sometimes in hardware cases. You can make the hardware, but actually making sure that it performs the way that you want to is becoming one of the major bottlenecks in software development also, and in hardware development now, as you have to update more and more constantly, and the time pressures to actually do the acceptance testing in a way that it's good enough is a major problem. And that's the kind of issue that we at Kentel have been looking at a lot with our products and that side and in the testing side. I don't know about you guys. Is this kind of level of discussion on the testing side? Is this something that's familiar to you, or do you want me to explain something a bit more or go into more details on some of these parts? Any comments on the kind of viewers?
Mr. Tero, Christian Stock, I have a question about this DevOps process. How do you see which interfaces has a DevOps model to requirements, software requirements engineering, requirements development, system requirements? Which interface could it have?
Onto a kind of like a more traditional process, or do you mean that that could be done asynchronously in that process?
Yes, integration, because DevOps is more process automation for software development is clear, but I'm missing.
Join the meeting.
I'm missing the part of requirements for the software.
Yeah.
This incremental development of requirements and deliver the software, integrate, commit the task, integrate, and so on. Because compared to vCycle, the classical development process, we have here more the right side of vCycle, but it's less on the left side.
Yeah, and that's a really good point that you bring up. That I myself do not see it only as a way to do software updates in a faster way. As basically, you have to have the requirements right so that you know what you're actually doing there. If you're just like quickly doing something, you're like your what is it called? Probability of doing the right thing gets lower and lower, and the less time you spend basically on planning. And I think pure idea of DevOps is not to kind of do something unplanned quickly, but to kind of still have the link to requirements management in a way that you want more specific or like more specific requirements in a way, or lean specific requirements in a way that you want to specify in specification work what is actually needed, and not too much how do I want this to be done, as that typically enables faster feature iteration. But of course, in environments like the automotive, you're really going to do that. That's kind of like a dreamland scenario that you could quickly just say, hey, I want to do what could be a good example. I want to do a thing which plays music according to the speed of my car, for example. Sounds simple enough. But when you start digging into that kind of specification, then you end up in a lot of corner cases that, okay, we cannot do this because of some standardization says that we have to take something into account, or actually the interfaces in there are kind of closed, or you cannot get that information easily. But I think also that link into documentation is getting, or specification of documentation is getting a lot more easier as because the environment is becoming more and more standardized and more software defined. You can actually much faster develop features basically on top of features already made there, as there are kind of API levels and all of that raises the abstraction of the software layer, enabling you to do like smaller specification in there. Of course, initially, I also believe that you cannot just do small specification and link it to a DevOps process. You have to have really good specifications in place. And I also myself am a firm believer in test-driven automation. So test-driven automation basically says that before you even write a single line of code, you think about how would I test that this feature actually works the way it does. And I think test-driven development is a really good way of doing DevOps with much more specification. When you need a lot more specification, then linking the kind of documentation with test-driven development in the development cycle is, I think, the really good thing. I think links it there. Let me go back.
Okay, thank you. It's more so test-driven.
And kind of when you do the kind of monitoring of what's actually going on in your current environment, you can then do the planning in there in a better way, and kind of doing it in a more, well, with testing, it's if you do test-driven development, then you also have to kind of be really specific, of course, with the criteria of the specification, as you have to be able to define the testing from there. So I think that also drives it in such a way that you do smaller but more specific specifications and iterations on top of something that you do. And that kind of forces you also, well, anyway, the environment kind of, I think, forces you into shorter and shorter release cycles. And that's what I think is now possible with more and more software-defined cars and automotive industry in there, because you want to be able to do 600 updates a year, for example, on a product that basically keeps getting better for the customer the longer they use it.
Yes, so customer orientation is bigger and so feature-based and feature after feature, so incremental development, and this is growing up.
Yeah, and then of course when you have more and more features, building a feature on top of those features adds to the complexity, which increases the testability problems of the whole system, and it's kind of self-feeding cycle in the other end on how do you actually validate all of that, and does it work the way that you actually want it to work. And you find that problem area, quite interesting on how could we solve that so that we don't end up in a situation where the system is just basically behaves every time in an unspecified way. It is the kind of theoretical direction where the system goes if you do continuous development on top of that. So you have a lot of gray area in the system.
Okay, thank you.
And that little segue into the specification side here is something that also feeds into the kind of acceptance and system test levels, I think, most on this quite quick way. And because if we can have a tool that or language basically to describe what the system should do in a nice way, it also provides you with nice test scripts straight away, which can really speed up your iteration cycle as you know what's going on in that system and its complexity. That relates to nicely into the abstraction level of testing, as of course with test automation you typically can do all of these different levels of testing. So reviews, meaning that somebody manually reviews the code base. Somebody goes through who knows how the code should behave. You can go through and read the actual code. And that means that the test amount quickly becomes problematic as you have to basically read every line and see how it interacts. But it's typically quite fast to test with automation. It's difficult for humans to do total testing of what the actual code does, but a lot of tools nowadays with code do kind of code review automatically. Are you using the best practices and are you doing it the way that the code should be written? Is there some kind of statistical problems in there that we know that typically result in problems? But of course, this is also been defined by humans. What are the kind of problems there? Static tests are again a bit of an abstraction of testing single functions in the code, easy to write for automation, a bit more difficult than human brain to interpret as they have to be specific. And the unit test on top of that, again, a bigger unit, one single unit inside of the software component. How does that work? Does it give out the right outputs and does it take the right inputs? And does that work? And then when we put a lot of these in together, we get integration test and then we get acceptance test, which cover the whole system. So this way, this is called a test pyramid, that you have a lot of, typically to achieve the same amount of test coverage for your system. In the bottom, you have a lot of test reviews. You can review all the code, or you can do some acceptance level tests, which basically an acceptance level tests, if it would be a web shop, you would go through, can I add a product to a cart? Can I take that cart into can I put my credit card in and can I get the actual order done? When you think about it, that covers most of the different modules in the software. And it's the same kind of thing in also in all of the other like IT-driven stuff in automotive and all of that you want to automate a lot of these processes, but the higher level of testing it typically becomes more and more difficult to test, as if, for example, doing acceptance tests for a car or any kind of a IoT system, you would have to somehow simulate it driving around a track or actually doing it with a physical product to do that level of testing. So the complexity and price of the testing typically is a problem on that side, but it gives you the best results, so you probably want to do it. And what we've been going through a lot is how can we make the tests like acceptance tests much easier, or how we can simulate them, or how can we do that in a totally different way. And this is kind of seen in automotive industry quite a lot nowadays, that the Scrum and Agile way of working is disrupting it quite a lot as it becomes more and more of a software industry. And why I think that is that basically many of the hello, did I break up? Because I seem I lost a bit of my internet at least. Yep, seems like I'm back. I think. So what I'm thinking is that basically the physical world is becoming more and more easier to program. With 3D printers, you can basically use programs to create physical objects, and this kind of a thing is also coming more and more into the manufacturing side and all of the other industries also, not just on the software side, but a lot of on other production side. It's becoming more and more easier to define the physical world software, and this combined with quite nice simulation facilities and all that will enable us to test out actual physical objects much more easily on the internet. And kind of that here's a really nice talk on how actually you can see the Tesla's new way of building car bodies and all of that as actually a build server for the kind of DevOps process in the real world, and how when you can actually use software to define that build pipeline. So what they've done is that basically don't have physical rigs on holding all of the car sides together. Everything is based on drop of hands, so you can adjust it as needed even between versions, and it's easy to customize basically the production line to do fit different things. Of course, here customization means you can change it in weeks, but of course in software customization means that you can change it in seconds, but we are kind of getting there. And there's a really nice talk, if you're interested, from 2018 actually, that kind of goes even deeper into this this like physical world as a software, but I'm not going to go too deep into that topic as I'm again more of a software guy. And even though I was working on actually a company that did factory manufacturing lines for 1.5 years, I didn't dive too deeply into it, just a little bit. But there's a really nice Clean Technica talk, which takes about 1 hour of talking about this side, and also he also brings up testing and validation as one of the key bottlenecks in there. And from here we kind of come into the software-defined car, and of course one of the main drivers that I've been doing and that I got most information about is of course Tesla being a good example of that. They cram in a lot more hardware than is actually needed on the car, and they can use software to design all of the new features in it, and use that to drive to kind of front load the development work. That you also have all the hardware in place, but we don't have the actual software features yet. We can get the product out into the market even though parts of the software and parts of that stack don't work, and kind of quickly iterate on that to get more and more value on that and get actual customer feedback out from customers in that side, in a way of letting your customers actually test your product in the field, which has all of that stuff already installed in it. Oh, and I seem to be missing one picture, but basically this was that Tesla currently makes about 650 updates a year to their cars, compared to the typical release cycle of maybe 1 or 2 updates on that side. So enabling kind of really fast iteration on the software side doesn't mean that the hardware actually changes, but just that the software can be updated because the cars are always connected. And they put the internet connectivity in 2012, and everybody was like, why are you putting internet connectivity in cars? It doesn't make too much sense. But then when they were then releasing first of the features, hey, we actually updated self-driving in there, and we actually updated some of the stuff in your car, then it started to make sense why they did that, as they can basically test out the hardware in real time. But there's a problem with this, which is of course the validation problem, how they can actually validate all of those software versions. And you've probably seen a lot of media coverage about that. Basically, all the Tesla cars are in permanent beta. So we get new features, yes, but they're not as of a good quality as with the typical process that you get. They are always they feel they are not 100% complete. And this is something that's kind of the validation problem, that how can you, that we were talking about in the beginning, that how can you actually test out all of the new software versions in a way that is covering enough so that you can actually be confident that you can release this feature to the client. And of course, with it being cars and with, for example, the self-driving field that they're doing, I would be very wary of actually pushing updates out there, as you might end up with, in the face of cars or automotive, maybe even killing people or some dramatic happening if those updates are not correct. So how do you validate that in a way that you can be confident that the whole thing works in a way that you want it to work? So how can we validate it faster and faster when we are doing modifications on a platform that also underneath us changes faster and faster? And that's I think is now the problem that's become that testing is the number one bottleneck in software development. And I think it's also become the number one problem in nearly all industries where you have software as the number one component. As testing and validation currently takes a little bit more time than development. And one thing is that testing hasn't typically been easy, and test automation typically hasn't been easy. Of course, now we as a company are kind of saying that we want to change that and do a lot of stuff on top of that, so that we want to make this problem easier, so the companies can actually release a lot faster than they can, and so the testing in itself doesn't take as much as time as it used to do, and kind of take the power of the cloud and take the power of the computing available in there to build testing solutions that run a lot of tests, to do it based on machine learning, do it based on probability statistics in a fairly efficient way to get it done. As testing tools haven't been developing on the same pace as all of the software tools in there, and now even hardware factories haven't been developing on the same pace. So what our answer to this is basically is virtualization. We've done a lot of virtualization and work around virtualization in a lot of different research projects and different fields. And what we want to do is virtualize a lot of these software environments. And initially, it sounds like a lot of custom work on a lot of different environments, a lot of different phases in there. But actually, one nice way of doing virtualization is taking something that's quite standardized around an issue that's used by many, and also something that's really clearly defined. As we were talking in the beginning, we had the discussion about standards, for example, or the kind of specifications. That those things are easy to test if you have proper specifications that actually tell you straight away what should I test and how does it behave. And that's why what we've been doing, and what we found out to be actually the answer for many of this problem is proper documentation and proper design up front, which is kind of the antithesis of the DevOps movement that I was kind of saying. That what we can basically do when we have a standard or something else, that we can use that to build really effective testing libraries, which can offer a lot of boost basically on top of the software development cycle. And how we come to AUTOSAR, which is one of the topics that we've been discussing a lot, and why we are interested in automotive and in other spaces, that there's quite a lot of open system architecture standards and otherwise in there. That a lot of people have used a lot of effort to create these different standards that provide interoperability between different companies, between different suppliers, and between different coders and operating systems in there. So if we can preemptively build test cases to conform to these standards and to this documentation, basically, we kind of front load the problem and kind of go around it so that we don't have to always make totally custom tests to make sure that your system works the way it does. And Emmanuel brought it up quite nicely that with this we can kind of link the DevOps process in to the actual specifications work. The specifications work can be done in another loop in another side of it, and then joined into the software development cycle, which is done then against the standards. And we think there's a lot of power in this kind of standard testing that can be taken into the cloud with a lot of research, with a lot of different open standards, and kind of companies helping out, fleshing out these kind of standards, and their test sets already have given them quite a lot of boosts in there on how to do this kind of testing. And as there's quite a lot of people already using, for example, AUTOSAR standards to do the testing, is that you can immediately, if we develop one or two test cases that can be used by all of these companies, the value that you get for that work is much bigger than just developing any kind of a test case for one company or something else. So this is a really nice way of getting past some of the parts of the difficulty in there. And we've been working with, for example, Tietoevry, which is a big Finnish software company doing a lot of projects on the automotive and basically everywhere, as they are now. I think they're now biggest software company in the Nordics, so they're pretty much everywhere. We've had really nice work with them, for example, about AUTOSAR testing for a couple of automotive partners, so that we can actually virtualize the devices and they can test their developer work against those virtual devices and not against actual physical hardware. Typically, when you're developing hardware solutions, you're constrained by the fact that you might have 2 copies, maybe even 3 copies in the lab, but that's it. And testing against that is problematic. But because of the standards, we can emulate those APIs and all the others, not based on the hardware that you're doing, but based on the actual standard spec. And that gives you a nice way of not bottlenecking your work with the actual hardware. And kind of typically the case has been that you have the developing team, hardware system, and testers all are there. developing on top of the local hardware. And I had nice animations in here, but for some reason my animations didn't work. But you can kind of get the story anyway. That what you can then do is put, if you have the AutoSAR standards-based test in between there, you can kind of de-link the team from the actual hardware and run the test on as many software simulators as basically possible, and you've not be limited by the hardware in there. And you can actually bring in more development teams to work on those issues if needed. And even third-party members can develop new features on top of that hardware or that standardized testing, not use your hardware resources if we can run it on the cloud. And this is the kind of premise that we've been working towards on making test automation in the cloud. And why we've been kind of staying also away from local environments, even though we do that also, that you can link your hardware lab in there and do it the same way. But the real power lies in the kind of virtualization that you can take the system, standard APIs, virtualize them into the cloud. And this why really speed up test automation, for example, so that it won't be the bottleneck in there. That's typically been the bottleneck in many of the industries and standards. There's also quite a lot of other stuff that isn't there, who are actually test automation experts. That's also a limited resource in the world. We want to also do it in such a way that you don't have to be a test automation expert to use that testing. So we've put a lot of effort in making our test scripting quite easy to understand on top of open standards, so that you can reason about it, you can talk about it to people who are not testers, you can talk about it to software engineers and all of the others in there. And after this, I could show you a couple of videos and a demo of it, but on what we think is really good and nice way of solving this kind of complexity issue that arises from more and more connected systems and the need to test much faster. So I've been going on here for, I think, 45 minutes at least. So I'll have a sip of Coke, and if anybody has anything to add to the discussion or ask anything, go ahead.